Greetings everyone, this is Carl Hurst and I'm showing you my pancake coil, magnifying coil, wound 25 conductor ribbon cable SSG system. It's a solid state runner and it'll also drive my bicycle wheel if I want torque or if I want to do cap dumping. There are different ways to do that. This one is running 12 2N3055 top hat transistors. As you can see, every one of the collectors is isolated from one another. That's very important in order to make sure that you have real parallel nodes as Gabriel Cron instructed. This is a temporary setup with a potentiometer just to measure the sweet spot resistance that'll make this the most efficient depending on which impedance load I'm running the system into. As you can see, I'm using these connector thumb wheels so I can actually screw down any size resistor I want. Currently it's running at 630 ohms for the sweet spot. Here you can see I've set up a voltmeter and an ammeter. A little shadow on there. There we go, ammeter. And that'll be measuring the power in from this small emergency power station, battery charger, yada yada yada. It's actually only a 4 ampere hour little battery in there, lead acid. It's currently sitting at 13.2 volts charged up. Over here we have the charged battery. It is currently sitting at a standing voltage of 12.3 volts, and that's a 12 amp hour battery. So this one is 3 times as big as the drive battery. So we'll be able to have a look and see how this thing charges across this parallel SSG system. If you want to look at the schematic or the back side of this unit, I've put it in the files sections in Benini Monopole 2 and Benini Monopole 3 in the Yahoo groups. So let's connect this puppy up and you can listen to the resonant audio tone that comes from running this. There it goes. Now you can hear it. You can see the voltage there of the input battery. I'm currently running at about 1/2 of an amp there. That is actually above the sweet spot necessary, so I can tweak that slightly with turning the resistor. There it goes. You can hear the tonal difference as well as the drop in. See, the higher the resistance, the higher the squeal, and the lower the input power, and that makes the input drive battery last. Now, over here on the charge battery, you can see we've got some charging going on. The lower the tone, the faster the charge. Of course, that also means that, there we go. So right now I'm fiddling with figuring out what's the actually most efficient drive in current for charge on the output side. As you can tell, it's charging very nicely on the battery, which is 3 times as large as the input battery, and yet we have almost stabilized the input voltage from the drive battery. That's going down very slowly. We're running at 440 milliamps right now, which divided by 12 is very little amperage going through each one of these top hats. The top hats stay cool to the touch. Even in solid state performance, every once in a while, number 12 down here warms slightly above ambient, but all in all, I must say, there's nothing running hot in this system. And right now we're using this small input battery for driving this system to charge this large output battery. And as you can see, charge rate's going up very nicely. If I'm in a rush, I can increase the input power and get this thing charged up very quickly. Now if I change the orientation of this big Neo magnet on top of my core, I can either remove it and it goes silent, but as you can see it's still running and the input current rose slightly. If I put the magnet back on, you will hear the tone and you'll see the input current drop. See that? And in different orientations of that magnet, I can get it to drop 20 up to 30 milliamps overall. And as you can see, our input voltage is still hanging pretty tight there at 12.48, while we've gone from 12.3 all the way up to 12.44 on the charge side from a standing voltage of 12.3 volts. So there, in case you were wondering about this strange wiring here, what I've done is every second wire leads to a transistor. The first wire is connected in series to the second wire, so that the way they are wound onto the coil, you wind up with exact parallel circuitry, which at some point when I wish to experiment with the magnifying coil characteristics of Nikola Tesla, this one would have to be driven at about 3.3 megahertz to get the standing wave to match the length at 300 feet of this wire in here. You'll note that all of the red leads in here, which are connectors to the transistors, appear to be different lengths. That's only because of the distance they have to stretch under the board. I have done everything in my power to make sure that every single connector and every wire is exactly the same length for later testing when I wish to do magnifying coil experiments. As I said, this coil will drive my bicycle wheel or any other rotor with magnets in it, and it is set up to drive all north-out monopole wheels. Something very interesting you will note here, even though we're driving at 0.46 amperes, the battery voltage in is actually rising. This can only be seen in radiant charging circuits built by Bedini. We got all the way down to 12.48, and now it's risen to 12.51, even though we are driving this circuit, and you can hear the coils oscillating. And we've gone from 12.3 to 12.48 on the charge battery. It's continuing to charge very nicely, and yet input battery voltage, even putting out nearly half an ampere, has climbed slightly. So I'm quite happy with this little setup. Lots of different ways that I can use it. I encourage people to try to build multi-coil systems with this method, because it's a lot easier than trying to get the timing and adjustment and measurements so precisely correct to hit a lot of different magnets simultaneously on a rotor, while with this setup you can run as many as you wish, as many transistor drivers as you wish, simply by stacking ribbon cable coils on top of one another and using a single core. A single core really lends itself to simplicity, and as you can see, it's pretty compact. I've got it on a cutting board. You can pick it up and you can move it around, and you can slide it under a bike wheel. Let's see here, you might be able to tell my bike wheel here, and all I do is just slide that board underneath my bike wheel, and it spins that bike wheel very, very nicely, so I can get torque from it as well as charging. Not that torque is very important when you have something that does this kind of nice charging. On the left, you will see that the drive battery has now risen to 12.52, and the charge battery has risen to 12.5 from 12.3 standing voltage. Note that these standing voltages were confirmed over a 24-hour period. I drained the standing voltage on the charge battery down to 12.3 volts last night, and it was still the same this morning, so there isn't any bounce effect in the voltages there. There might be a little bit of bounce effect from the initial draw on the input battery, but this is still pretty unusual to see nearly half an amp draw on a 4 amp hour battery and having the battery voltage rise on the input drive battery. This is really a sweet thing, and I've only discovered it now at the same time I've been talking to you folks out there. So there you go. If you have any questions, post them to the Yahoo groups and we'll go from there. But basically, very simple setup, and it just goes again to prove John Bedini's observations that there's a lot of power out there to be gained through switching. This is all about switching. It's not about rotational mechanical power to drive a bike wheel, even though it can be done. It's not very efficient for that, but for charging, it shows that there's something going on with this high rate of switching, which is pulling energy into the system. And that can only happen when you have the instant on spikes, which we're harvesting here with a series of 12 heavy diodes, all leading to one copper heavy bus, which leads from here to my charge battery. So that's Carl Hurst, 3rd of October 2010, with the 25 conductor ribbon coil or ribbon cable SSG Gabriel Cron parallel node setup. And by the way, that one extra wire you see hanging out there, I've left the center conductor in the ribbon free just so I can do testing with it and measuring currents and voltages and things like that. Take good care and God bless. Bye-bye.